Welcome everyone. We are Unit8 Talks. This is our webinar series on business and technology. My name is Billy Yen and I'm your host for today. For those of you who don't know us, we are Unit8, a Swiss data analytics and AI company driving the adoption of data science in industry and committed to sharing our best practices. This session is for you, so feel free to ask the question on the platform you're using. We are live today on LinkedIn, Twitter, and YouTube. This session is recorded and will be available on our website in a few days. Without any further delay, I introduce you again, Fabian and Jacob. Guys, the floor is yours.
Hi, everyone. Thanks, Billy. My name's Fabian Schramm. I'm one of the customer engagement managers here at Unit8, responsible for customers in the DACH region and Northern Europe. And joining me today is Jakob.
Hi everyone, I'm Jakob. I'm a senior consultant here at Unit8. I was at IBM before that, consulting companies in digital manufacturing. And before that, spent 1.5 years in research institutes where I made hands-on experience on AI use cases in manufacturing.
Awesome. And without any further ado, let's jump into it. In case you have any questions throughout, just throw them in the comments and we'll try to answer them live as best we can.
Good. Yeah, let's just start. My screen does the screen look green on the?
No.
It's good? Okay, perfect, good. Yeah, so the agenda of today, we're going to talk about AI manufacturing. First, we're going to give you an overview of what it is and how it's adopted in the industry. Then we're going to talk about challenges, which we commonly see. Then we're going to give you AI use cases and also demonstrate an example that we have implemented with a client of us. Then we're going to talk about how to identify use cases and implement them in a scalable way. And again, give you here an example of a project that we did. And then we're going to talk about data platforms, show you how we implemented a data platform for one of our clients in manufacturing. And then we're going to close the sessions with lessons learned. So let's start with the first section, overview of AI manufacturing. And spoiler alert here, AI is a buzzword. There's no intelligence in artificial intelligence, right? When we talk about artificial intelligence in manufacturing, we mean applying data science to increase the overall equipment efficiency. So that means improve quality and yield, reduce downtime, or increase performance. Anyone in the audience, if you know of any cool AI use cases in manufacturing or even data-based use cases in manufacturing, leave a comment and we can revisit them later. So why AI manufacturing is a very, very promising field. Different studies show that companies around the globe struggle to apply it successfully. Here's an example of Deloitte, and that says that only 15% of those companies that have applied AI brought it to a successful project state. And several other studies exist from other consultancies and other research institutes, but they all show more or less the same number, which is that 70 to 90% of AI projects in manufacturing fail. And the question is why? We believe that a lot of it is due to like common challenges that we also frequently see in our engagements. And you can, if you look at this iceberg picture, the successful implementation of AI in manufacturing is really only the tip of the iceberg, but you have to do a lot under the surface to enable it. So one type of the challenges that we see commonly are, let's say, data-related challenges, right? Those could be data silos. So that means that you do not have access to all the data that you need for your AI-driven use case, for example, a predictive maintenance use case. Non-machine readable data. Let's say you want to access maintenance records. They are often in files, even handwritten, and it's really hard to access this data. You have unconnected data sources, heterogeneous machine landscape, which means some of your machines are 10 years old, some of the machines are 30 years old, and it's really hard to connect the data. Heterogeneous data standard, and also, of course, real-time requirements, or at least assumed real-time requirements when applying AI in manufacturing. Here again, if you know about any use cases with real-time requirement and in AI manufacturing, let us know in the comments as well. So those challenges are seen across the all kind of different industries, right? Could be in the chemical industry that we're also going to cover today, could be on the automotive sector, or for automotive suppliers, could be in the energy sector, and also for other sectors, for example, like if you're an airplane or an airport operator. But another type of challenges that we often see is called, let's say, organizational challenges towards AI. And that starts with unrealistic expectations. So as said before, AI is a buzzword. There's no intelligence in artificial intelligence, so to say. And that means that every stakeholder who is involved in AI in manufacturing and applying AI in manufacturing needs to be aware of the possibilities and the limitations of AI. Then the second is reason that we often see is no investment in data infrastructure. People sometimes hope that AI enables them to find useful, impactful data patterns in the existing data, and that is unfortunately not the case. And you cannot answer the lack of quality and availability of data with complex AI solutions. We see island solutions. That means that, for example, individual departments along the manufacturing process have implemented the small AI POCs and pilots, and that often fails because they didn't do the homework. For example, answer those technical challenges that we've seen before towards data silos, data standards, and so on. And one of the biggest organizational challenge towards AI is the lack of return on investment. So that means that often companies select a use case which has not business impact, and this will then automatically fail after a while. We're going to talk today a lot about how to overcome all those challenges, but we would like to start to talk about our experiences by giving you an overview of AI and data-driven use cases. So here in this matrix, you can see different use cases. Let's just quickly go through them. One very impactful use case that I have seen and that we have seen is the identification of production bottlenecks. That means that imagine you have a production line with 100 steps, and at some point of production utilization, one production step or one machine in your production line is going to slow down the entire production process because it can't keep up with the speed of the other machines, with the production speed of the other machines. Data can help you to identify that, especially when the utilization, for example, of your production line varies. Another very impactful use case that I've seen is quality tracking. That means how does the quality of the production piece that travels through your production line change over time? This can help you, for example, to identify machines and processes that have a negative impact on your production. Then detect process anomalies. For example, a process is suddenly going slower or needs more energy. And then there are also use cases which require really advanced AI. Classic here is predictive maintenance, either for standalone machines. For example, let's say you're operating a turbine as an energy company, right? Also for production lines. So you want to predict maintenances for a single machine in your production line. This predicting and maintenance for a single machine in production line is often a bit more complicated because it's influenced by the machines around it, and you need more data, and the approaches are often more complicated. And then there's, of course, quality anomaly detection, for example, based on computer vision. You see here we structured those use cases in 2 dimensions. You have use cases where you need data from the overall production process or line, and you have use cases where you focus on a single machine. And then the other dimension, you have use cases which are enabled by simple data analysis, and you have use cases where you require advanced AI, for example, more complex machine learning approaches. Based on our experiences, however, the use cases on the left are often more impactful than the use cases on the right, on the bottom right. However, the ones on the bottom right are often easier to explain, easier to identify. So we would like to start with one example that we have implemented for an energy company. And Fabian, with that, I will pass the mic to you for the first time.
Thanks, Jakob. And Matteo, regarding detecting production bottlenecks, if you've got a bit more details around your question, throw them in the chat, and I'll make sure to address that as well. So one of the areas that I want to focus on is we were working with the hydropower plant, and they were working with massive turbines. So power plants use turbines, and these turbine machines, they cost upwards of $10 million per machine. These machines were generally newer, so they were 3 to 4 years old, and they already had a lot of real-time sensors built in. And the power plant was looking to see how they can predict failure rates or reduce the risk of failure ahead of time. So typical predictive maintenance. This wasn't to say, hey, the temperature sensor spikes and it should be 80 and now it's 100 degrees Celsius. That is already built in. That's, let's say, more basic predictive maintenance topics. Here, we really wanted to detect the anomalies over longer periods of time. So each of these turbines have roughly 30 temperature sensors spread around the different bearings, spread along the different pads. And what was happening was this data was being loaded into a historian database. And in this case, it was being pulled out of that database into Seek, a data platform. And that data was streaming in 1 second intervals into the historian database. We were then uploading it into Seek in as a batch data file, because here we're talking about real-time data, but the actual analytics use case isn't real-time analytics. We're still using batch analytics here. But what we were doing was we modeled the historic data of how the temperature is evolving. And we then took that 24-hour batch period and said, we expect the next day's temperature to vary within this confidence interval. And by doing this over days, weeks, and months, you're able to see patterns that you otherwise wouldn't be able to detect. By seeing how that confidence interval evolves over a week and month period, we're able to identify, hey, this machine has increased temperature by 0.01% over the past 3 months. Why is this happening? And the nice thing here as well, we were working with the mechanical and the electrical engineers who are operating this plant. And with their backgrounds, they had a very solid understanding of how this machine was functioning. And together with our data science expertise, we're really able to understand how these temperature fluctuations are impacting the machine and what measures they as operators need to take to alleviate some of the pressure on that machine. I hope that that was clear. If you have any questions, again, feel free to throw them into the chat. And back to you, Jakob. And you're on mute.
Thank you very much, Fabian, also for that. Yeah, that was a very cool use case, but it's a use case, let's say, that is easy to identify, right? But let's say you don't operate like a single turbine, but you have this complex production process. How are you going to identify and prioritize the most valuable AI use cases for your production line? Because it might not be predictive maintenance. And the answer to this question is really involve your operators if you're a production company, because they know which insights matters. So how we would approach that is, first of all, emphasize and understand your operators, mean get an understanding of the production process of the industry, maybe even. Then collect and prioritize challenges and ideate together for solutions. This could be done with approaches similar to design thinking, and then build and deliver together. So now let's say you have identified, 20, 30, 40 use cases, and then the next step is to prioritize them. This is a very typical approach for that. You prioritize them based on their business impact and their technical feasibility. So if you have a use case that is very, very feasible and has a very high impact, you should start implementing this use case immediately. If you don't, it's often better to start with the ones on the bottom right than the ones on the top left, because the ones on the top left, they're often very impactful, but also very complicated, so you could get lost. Whereas on the bottom right, they still have some business impact, and you can really learn from them and then do the ones on the top left later. So our key learnings here are really only target those use cases which have some business impact. If don't, avoid doing them, even though they might be fancy. Feasibility beats impact, as I've said before, and also be honest about feasibility. Sometimes when you realize during the project that the data quality and availability is not what you expected, it can be frustrating. And now let's say you have prioritized the use cases in a roadmap, then the question is, how are you going to implement them, right? Because you don't want to just implement one use case, you want to implement all of them that bring business value, business impact. And the idea here is to do it in an agile way. And that means, first of all, select one or at least a few pilot plants or production sites that you focus on. There's no reason to try to implement everything for all the production sites around the globe that you have in your company. Focus on one. And then in that, like, start with a simple proof of concepts, and then bring them to production, and then scale them, for example, to include other business or manufacturing cases, or implement the next POC and bring it to production. And while you do all that, continuously build your data foundation to enable those use cases. We're going to talk about this later, but what's really important to understand here is that, when a use case needs data, make this data available in a good quality. So the key message of this slide is really to dream big. So identify all the use cases that have impact for you, but then start small. So one side, one use case in the beginning, and then scale smart. And scale smart means always revisit the technical feasibility and also the impact of the POCs and pilots that you have implemented before you start scaling. We have worked together with one of our clients over the duration of 4 years, where we followed exactly this approach, and Fabian will now tell you about it and give you insights about the results.
Thanks, Jakob. So in this case, we're talking about a chemicals company, and they initially reached out to us, about 4 years ago, where they were just at the beginning of, let's say, their data and analytics journey. And they had on their production floor, we're just having some challenges. They'd gone through tried to go through some process improvements, some Lean, some Six Sigma initiatives. But then their plant managers were saying, let's see if we can do something in the space of advanced analytics. And we started working with them. And the initial thing that we wanted to do was, let's understand the process from really beginning to end. And that included collecting, I know it says Azure up in the slide there. Azure happened later on. Initially on the project, everything we were doing was still on-prem, but it was trying to understand what sensor data is available. Can we aggregate that sensor data? What data is coming from maybe batch records? What data is coming from the operators themselves? Getting a clear picture of how that process looks. Jakob, I think if you click one further, so this is kind of the process map that we got out of that. And each of those blue dots represents a data source that comes in as a more sensor data like, and each of the green areas is a process step where we're able to get data from the operators themselves. And by understanding this process, we were able to identify different areas of the production line that had room for improvement. One of the big ones that we were able to get was from the sensor data. One of the sensors was throughput, a flow throughput sensor, which gauged how much liquid was flowing through particular valves. And we were able to analyze the flow rate of these chemicals and understand that these valves were actually clogging over time. And if these valves clogged during live production, it created issues because the chemical mixtures weren't in line with what they should have been, which resulted in having to stop the production line, clean the valves, and redo certain parts of the production stage. By aggregating that data into, let's say, a monitoring dashboard, we were then able to tell the operators, hey, this valve is starting to deteriorate in the sense that the flow rate is decreasing. And they're able to then predict, proactively say, okay, at the end of the week or at the end of this shift, these 17 valves, and we're talking about thousands of valves in this case, so identifying which ones was really important, and it saved them a lot of time. But this, in combination with other initiatives, actually increased the overall equipment efficiency by over 10%. And in this particular line, we're talking about a 7-digit Swiss francs of annual savings. And now they're working on scaling that across additional plants, which they've done over the years now successfully. And over time, we've also moved this into an Azure environment, in this case, for easier data handling and also driving some more data initiatives. But this is how it started, and you can see kind of how that progression, how it's still continuing to evolve today. Back to you,
Good.
Jakob.
Thank you. I was waiting for that. Yeah, thank you very much. And that already brings us to our last session of our small webinar today, which is establishing a scalable data infrastructure. You can see here that a lot of your POCs or pilots and on the process of production scaling, they require a lot of data from a lot of different data sources. That could be sensor data, master data, plans and recipes from an MES, also like images maybe, quality data, and even like data which is not really manufacturing data, for example, R&D data. And the problem with this data is that it is not initially stored for analysis. It is stored to enable your production processes, for example, to control them, manage them, monitor them, or maybe even for auditing. And this leads to the problems from a data scientist perspective that the data has a very low quality, for example, lack of standards across data sources, and also low availability. So the question is how you're going to make all this data accessible over your production line to enable data-driven and AI-driven use cases. And here the answer is data platforms, because they provide this very scalable, simple data foundation, which simplifies the life of your data scientist. This is a very simplified architecture of a so-called data platform, but you can see an ingestion layer from where data from your different data sources is ingested into the platform. Then you have a data lake where data can be transformed. So while the data across your different data sources may not have high quality, here you can really like standardize data across data sources, store them in analysis-friendly formats. That means, for example, data is not in Excel files anymore, but now in a cool database that is much better for your analysis purposes. And you can also match data from different data sources to each other. And then, based on the data in this data lake, you can analyze it, for example, to generate simple insights, to develop advanced machine learning models, or if you have edge requirements, you can use this data platform to train a model and then deploy the model to an edge device, so you can fulfill real-time requirements. What is important to notice here is that there's really no reason whatsoever to try to put all the sensor data you have into this data platform and very nice quality and availability. Really, the ingestion of the data, so for example, is this done on an hourly basis, is it done on a daily basis, is defined by the use case needs, and so is the transformational data lake. And especially also the data which you ingest into this platform is also defined by the use case needs, because our lesson is really data lakes which do not provide any business impact will die automatically. So yeah, Fabian, for our last example where we've implemented such a data platform in the manufacturing context, I will pass the mic to you again.
Thanks, Jakob. So I think we've gone through, we started with an energy company, which was, we're talking about a particular machine, getting that data into, from a historian database into the Seek platform. Again, a nice platform where the data scientists via the Seek Data Lab were able to do their analysis. We had previously starting on-prem, migrating that into eventually a monitoring solution, which was hosted in Azure. And now we're going to touch on another example. This one, again, focused on AWS side of things, but the elements are very common in the sense that our goal is to aggregate the data sources that are necessary for us and give the data scientists or the business analysts a space to work with that data. In this case, we had a global pharma company that had a production line that was doing, close to $500 million worth of product every year, and they were reaching capacity. So they had the decision whether they can get some more output out of their current production line or whether they needed to build a second production line, which obviously takes multiple years. They as well had gone through different Lean and Six Sigma iterations to try to improve that output as much as possible. And then they as well said, is advanced analytics an option? Can we derive anything from that? And we followed also how do we identify which projects to go after? So we came up with roughly 40 ideas on different areas that we can work on. And we did that by talking with the plant managers, understanding what data sources are available, understanding the batch records that are available, speaking with the blue collar workers that are operating these machines, really getting a holistic view of what's happening, and then came up with these 40 ideas. Those 40 ideas were then narrowed down to 13 ideas. And then those 13 ideas actually ended up with 6 ideas that were implemented. And I think, Jakob, if you click once, so there's different aspects that these 6 ideas covered. Some were more on an operational aspect, some were really on a data analytics aspect, and some were even changes that we made to the actual machinery that was being used. In this one example, again, that production bottleneck topic. So here, step 2 in this production, this is obviously oversimplified, but step 2 was taking much more time and creating delays. So we focused particularly on step 2, trying to optimize that, because an optimization on step 1 or step 3, although it might be nice, it wasn't going to deliver any of that business value that we were looking for. You can click one further, Jakob. Here, another example. This was, we're talking about a pharma company. So they were making, tablets, medical tablets. And one of the steps here is in the batch drying machine. So this industrial dryer that is drying this chemical compound, and the drying was historically done run it for 25, 30 minutes, check, oh no, it's good, it's not good, run it for 5 more minutes. And what we did is we built a simulation to model when the best moment to stop the drying is based on the amount of volume of batch that's in the dryer at that moment. So the operator always knows, okay, I'm loading 800 kilos of batch into the drying machine. Based on that, model simulation says this needs to run for 27 minutes, and this improved their drying times considerably. I also mentioned a hardware aspect. This again goes back to that bottleneck topic. One of their machines was it's a tableting press. So if you look at tablets that you buy, there's often a brand name or a number on those tablets. The actual press that does this plant had a single press that was engraving these tablets with a particular number. And this was a big bottleneck for them. So what we did is we worked with them to say, hey, is there any way to make this single-headed press a double-headed press, which doubles the amount of pressing that can be done? And it was such a simple idea, and yet it helped improve their throughput by being able to double and removing that bottleneck. The point of this is we had a lot of different data sources coming together that allowed us to get this overall picture. And it wasn't this one breakthrough revolutionary idea that delivered all of the results. It was a combination of these 6 ideas that ended up delivering a 10% OEE improvement and 5% reduction in process times. So for this particular manufacturing plant, it was an 8-digit Swiss franc increase in their revenue on an annual basis. And this was a flagship project for them that they're now able to scale across similar production lines, but as well new production lines. They're taking the same approach that we took in regards to identifying those ideas and scaling it. One of the big important factors that I still want to mention, we really got the buy-in from the operators of these machines. If you're in the manufacturing space, the analytics ideas that you're generating, they need to have an acceptance by the users. So by having the users involved in the planning, in the discussions when we were trying to understand their process, it made the acceptance much easier when we came back to them and said, hey, this is our idea. What do you think? Yeah, this makes sense because I gave you that input. So getting that buy-in from different users, from different stakeholders across the different parts of the process is really important. And that plays into that cultural aspect of really becoming data-driven, not just in a single department or single hierarchy, but really across a company. I see, Matteo, you were asking, does your simulation approach, digital twin simulations? So in this case, the model itself, we didn't have digital twins of the actual machines, but what we are approaching is a digital twin element in regards to the overall process. So we had a simulation in regards to this is how the process flow looks. We didn't have a dedicated, let's say, digital twin simulation for every single machine. The drying step, yes, there was some digital twin simulation going on there, but again, our goal wasn't a particular, let's say, data science application. So it wasn't to do digital twins. It wasn't to do deep learning, but certain elements of that do come into play. But in the end, our goal was what can deliver value. And if that's can be a more simple model, we'll often actually go with a more simple model instead of a more advanced one because it's easier to manage in the future. And again, each of these initiatives then has ML ops initiatives that follow afterwards to make sure that the upkeep continues in the future. I think that's it from my side, Jakob. I'll hand back to you. Again, feel free to throw your questions into the comments, and or if I don't answer something, tell me as well, and I'll try to explain it in more detail.
Thank you. So maybe to emphasize here again, the company already went through traditional optimization processes like or approaches like Six Sigma and Lean, but really data enabled them to identify this production bottleneck, and that enabled them to come up with a better solution, right? To get those enormous business results. So let's close the webinar for now with our lessons learned. And the most important lesson learned for me is that AI and data can be impactful if you do it right. So we've seen in a previous example, a business impact of 8-digit Swiss francs. So 10 or more million francs. I think that's huge. But if you go back to our iceberg picture from the very beginning, the other lessons learned are that this success is really only the tip of the iceberg, because under the surface, you need to do your homework. And the first lesson learned here is really to include your operators, because they really help you to identify which insights are helpful and have a positive impact on your business. The second lesson learned is dream big, but start small and then scale smart. So establish an agile way of working, focus on one production line first and then scale to others. And also a big lesson learned, simplify the life of data scientists by increasing the data availability and quality, for example, by investing in a data platform. That sums up our webinar. I think there are no more comments left. So Billy, I think we can pass the mic back to you. Billy, you're still on mute.
Sorry, and thanks, Jacob.
You're welcome.
Great session. We'll give you a few seconds if you want to ask a question. Feel free if there is something that triggers your attention, something you want more details on, or any details on some use cases. Feel free to ask in the platform you're using, or you can also contact us. You can visit our website, unit8.com, and feel free to write to us, and we'll get back to you with pleasure. It was a great session about AI in manufacturing, expectation versus reality. We hope that within this discussion, you understand a bit more about the use cases and how to scale your project. I hope you also enjoyed the session. It will be available on our YouTube channel and our website pretty soon. You can follow us on LinkedIn, YouTube, and Twitter to be updated about our next session. Thank you again, Fabian. Thank you, Jacob, for the engaging one. And we all wish you a wonderful day. Bye-bye.
Thanks, everyone. Bye-bye.
Bye-bye. Thank you.